Hello friends, today we are going to discuss Introduction of Metrology, chapter number 1. In that we are discussing the various characteristics, or we can say the various terminology terms used in metrology. At the end of this section, you should be able to explain the testing parameter used for given instrument and calculate the least count of basic measuring instrument. Now first one is the various terms which are used in metrology. There are different terms which are divided into two types. One is static terms and second one is the dynamic terms. We are going to discuss. The first one is accuracy. The accuracy is the most important term which is related with the instruments which are used in metrology. The accuracy is nothing but the degree of agreement or degree of closeness between the actual measurement and the true value. Whatever the value we have decided for that part, and after manufacturing, whatever the dimension is there, the difference between that two, that means actual manufacturing value, and we have set the standard one or true value. That difference is known as the error, and the degree of that difference or degree of that closeness is known as the accuracy. Here you have to remember that the difference between that two is not accuracy. If that difference is known as error, and if the difference is very much less, then we can say that that instrument is an accurate one, and if the difference is more, then there is a no accuracy or accuracy is less. Now second term that we are using, that is precision. Precision is nothing but the repeatability of measuring process. If the instrument showing the same reading when we measure the same object again and again, and at that time if the instrument gives or produce the same set of reading, then we can say that that instrument is a precision instrument. The definition is the difference between two consecutive reading measured by instrumentation or instrument is known as precision. That means consecutive readings should be nearer to each other. If the consecutive readings are nearer to each other or their spread is less, then we can say that that instrument is a precise one. And if the spread between the readings are more, then we can say that that instrument is not a precise one. Here the high precision means tight cluster or repeated results, and low precision means broad scattering. That is the precision. Now here this flow diagram shows the basic accuracy and precision, how it works. In diagram number 1, if we see, if we see whatever the target is there, this is our target value, or we can say the true value, and this is the acceptable one. That means up to this we can accept. Now if we take this 6, 7 reading, all these readings are nearer to the standard or nearer to the true value. Then here we can say that all the readings are closer to the true value. That means their difference is very less. Then it is an accurate one. And again all these 6 or 7 readings are nearer to each other. That means there is a repeatability of that measuring value. Then it is also precise one. Hence this diagram number 1 shows it as accurate as well as precise one. In case of the second, here if you see, all the readings are scattered, which are slightly away from the target value. That means it is nearer to the or closer to the target value, that means it is an accurate one. But if we see all these values are get spread from each other, that means their spread is more, hence this is not precise one. In case of the third, all the readings are nearer to the target value, and they are nearer to each other also, that means their scatter is not there, hence they are having a cluster which are very narrow spread, hence it is a precise one. But as this is not from nearer to the true value, this is apart from true value, hence it is a not accurate. And in case of the fourth one, the values are spread, some values are away, get spread beyond the tolerance limit, that means it is not accurate, as well as they are not closer with each other, they are again spread, that means they are not precise as well as not accurate. That means here these are the four cases we can say, and from this we can say that if the instrument is accurate one, it should be precise one. But if there is a high precision, there may not be a accurate one. That means if accuracy is there, there should be the precision. But if there is a high precision, there may not be a accurate one. This is the accuracy and precision. Now we are explaining about this accuracy and precision with the help of some readings. Suppose a sample of A having a dimensions. These are the dimensions of sample A part: 32.56, 32.55, 32.48, 32.49 and 32.48. These are the 5 readings for sample A is taken, and if you observe these readings of this 5 set, then we see that the maximum reading of the job is 32.56 and the minimum reading is 32.48, and hence their dispersion or the spread is within 0.08 mm. In the same way, if we take another sample B having a dimension 15.38, 15.37, 15.36, 15.33, 15.32, and if we observe this second set of reading, we observe that maximum value is 15.38 and minimum value is 15.38. That means the sample B reading is spread within this 0.06 mm span, and hence we see that for sample B the spread of readings is lower or less, and hence we say that the sample B is more precise one. That means whatever the instrument is there using for sample B is more precise than the sample A. Okay. If we consider the same set for this sample A, the basic reading is suppose 32.49. That means the true value for this may be the 32.49 is the true value. Okay, then we say that all these dimensions are closer with this true value. That means we say that the sample A has a accurate one. And in second case, if the true value is 15.61, this is the true value, then we say that in case of the sample B, all these readings are away from the 15.61, which is a true value we require. Then we say that in sample B, these are precise one, but this is not an accurate one. Got it? That means accuracy is related with or concerned with a true value, and in case of the precision, the precision is related with the set of readings. It is not related with the true value. One more example for the accuracy and precision we will discuss. If the weather temperature is 75 degree Fahrenheit outside and it is really a 75 degree Fahrenheit as per the thermometer scale, that means the actual value and the value shown by the instrument is same, then we can say that that thermometer is a accurate one. In second case, if the thermometer consistently registers the exact temperature for the several days, that means if we measure the same environment temperature outside again and again, and that shows the 75 degree Fahrenheit with the same instrument, then we can say that the thermometer is also a precise one. That means here again we see that this accuracy is related with the true value, or there is a comparison with the true value, but in case of the precision there is no comparison with a true value, there is a comparison with each other, whatever the sets of the readings are there. Now second case, precise but not accurate. Suppose a refrigerator thermometer, a thermometer which is placed inside the refrigerator, shows the readings as 39.1 degrees Celsius, 39.4 degrees Celsius, 39.1 degrees Celsius, like this. These are the near about 10 readings, and the real temperature inside the refrigerator is 37 degree. That means the real temperature, or we can say the true temperature, is 37, and whatever the readings we have taken or thermometer shows are 39 point something. That means the thermometer shows the temperature which is away from the true value. That means we can say that thermometer is not accurate. But if we observe the readings which is shown by the thermometer are spread around 39.1, 2.4, 0.3, like this. That means they are very close with each other. Then we can say that the thermometer is a precise one, because the reading set of readings is get repeated but not accurate. This is the example of the instrument is precise one but not accurate. Thank you.